Hello, in this video we're going to be talking about how to use descriptive statistics. There's two main objectives for this video. The first is that after watching this video you should be able to utilize ratios, proportions, and rates to report nominal data. The second is that you should be able to utilize measures of central tendency and variability to report ordinal and continuous data. So let's start off by talking about the different types of data. So we have nominal, ordinal, and continuous data. Nominal is when data is divided into mutually exclusive groups or buckets of data. And this could be males or females, yes or no, the patient died or lived, they have the disease or they don't have the disease. Nominal data does not have any hierarchy, whereas ordinal data does. So with ordinal data, as you move from one point to the next, there's some meaning there. For example, as you move from one rank of the military to the next, you go up in prestige, but going up from one rank to the next may mean different things at different points in the ranking system. Pain scales is another example. A patient going from a pain score of 0 to 1 may show something different than a patient moving from a pain score of 9 to 10. Continuous data also has various intervals or increments. There's really an infinite number of increments for continuous data, and it's limited by the measurement tool. But as you move from one point to the next, the value is equal. So moving from one point in temperature to the next always means the same thing. There's two different subtypes of continuous data. The first being interval, and for interval data the 0 point is arbitrary. So 0 degrees Fahrenheit does not mean that there is no temperature. Whereas with ratio scale data there is a true 0. 0 kilograms of weight means no weight. 0 systolic blood pressure means the absence of systolic blood pressure. Now, how can we summarize these types of data? Well, we can use counts, ratios, proportions, or rates. Counts are really the simplest way of describing data. For example, we could say 20 patients with diabetes experienced a heart attack at my local hospital. But this isn't really all that useful. There's no denominator, so we don't know out of how many, and we really don't know the length of time. Ratios do have a denominator, but the numerator and the denominator don't necessarily have to be related. You can have a ratio of male pharmacist to female pharmacist. This ratio does not have units. There are ratios with units, for example BMI or body mass index. This is measured in kilograms to meters squared. A proportion is another useful way of reporting data, and the difference between a ratio and a proportion is that the numerator is in the denominator. So for example, you have a certain number of patients that experience an event, and that is indicated by A, and you divide it by the patients that had an event plus the patients that did not have an event. You can multiply this by 100 to get a percentage. So for example, we are going to look at a study where we're looking at weight loss to see if a drug can cause more than a 10% change in body weight. And in the numerator there were 10 events of this occurring out of the 100 patients total that we see in the denominator. Now we can easily multiply this by 100 to get a 10% occurrence of more than 10% weight loss. Lastly, now rates have the units of proportion, the A over the A plus B, but then they also incorporate time in the denominator. And it's often multiplied by some type of base, like per 100,000 people. This is how often this event occurs. So I have some codes here. DH means those that died with heart disease versus AH is those that were alive with heart disease. So let's say we did a survey and we saw that in 1 year 500 patients died with heart disease versus 7,500 did not. So if we add those together on the bottom, we get 8,000. We take 500 divided by 8,000, and then we multiply that by the per 100,000 people, and we get 6,250 deaths per 100,000 people. And let's say we had surveyed people that were between 70 to 80 in the year 2016. Now you can change this number per 10,000 just by moving the decimal place by 1. There's some special types of rates called prevalence and incidence. Prevalence is the number of individuals with a disease at a specific point in time, and you divide that by the population at risk. This is commonly found in cross-sectional studies. And then the difference is that incidence is the number of new cases during a period of time divided by the population at risk. You're going to more likely see these in cohort-type studies. So now we've talked about how to report and calculate nominal data. Let's move on to ordinal and continuous data. And the way that we summarize this is by using various measures of central tendency and variability. So when we talk about measures of central tendency, we're trying to describe the middle point of the data. And there's some different ways to do this. So one way is taking the mean or the average of the data. And so the formula is the sum of the data divided by the total number of data points. So we would add up 24 plus 54 plus 16 plus 34 plus 22 plus 11 plus 27, and then we would divide it by the total number of data points, which if you count those up is 8. Now you can also type into an Excel sheet equals average and select the cells that you want, and that this is a little bit quicker. Mean is sensitive to outliers, so it can change the mean significantly if you have a small number of data points. Especially in this case, you could use a median to describe the middle point. You typically use means with continuous data, whereas medians we typically use with ordinal data, and medians describe the middlemost point. In Excel, you can highlight the data that you want and type in equals median to get the middlemost point. Mode is the most frequently occurring data point. So if we look at the data set here, we see 44 occurs twice, whereas all other values occur once. So 44 is the mode. Again, you can type in equals mode into Excel, and that will do this for you. You can have bimodal distributions that have more than one mode. So if you had 44 and 44 and 55 and 55, you would have two modes. You'd have bimodal distribution. Now let's talk about measures of variability. So how can we describe ordinal or continuous data? So we have some options. We have the range, the interquartile range, the standard deviation, and the confidence interval. We'll cover confidence interval in a different video. So range is simply the lowest to the highest point, and you can type this into Excel by using the min and max functions and highlighting the data. We have the interquartile range. This is usually what we use to describe ordinal data, and it's variability related to the median. So you could go from the 25th to the 70th percentile, and you can type this into Excel using the equal quartile, highlighting the cells, and then having a comma 1, that's quartile 1, and then doing the same thing for quartile 3, the 25th to the 75th percentile. Now, to describe continuous data, one common way of describing this is the standard deviation. To get to this point, however, you must calculate the variance, and this can be a little bit tricky. The first thing that you'll want to do is calculate the average. So the average for these four numbers here is 4. And so if we look at the numerator on the top of this equation here, you sum up each observation minus the mean squared, and you divide that by the number of data points minus 1. So this is what this looks like. So we have 2, that's that first data point, minus 4, and then we square that. And then we add the next observation, that 3 here, minus 4 squared, and then we add 4 minus 4 squared, and then the last data point, 7 minus 4 squared, and then we divide that by n minus 1, so there's 4 total data points minus 1. Now, to do this a little bit easier, since if you have a lot of data points, it's not really realistic, you will want to type this into Excel. And really we're doing the sample variance here and not the population variance. That would be a different calculation. Most likely you will not be doing population variances because you would have to have a lot of data to calculate that. Now if we manually went back up here and did this calculation, we could see 2 squared here is 4, 1 squared is 1. This is 0, and then 9. So 9 plus 1 plus 4 is 14 divided by 4 minus 1. So 14 divided by 3 comes out to 4 2/3. And then we square root that to get the standard deviation, which in this example is 2.16. Or again, easily just typing this into Excel and getting the standard deviation in that manner. So in summary, for nominal data, you'll want to use ratios, proportions, or rates to describe your data. For ordinal, you'll want to use the median and interquartile range. And then for continuous data, you'll want to use the mean and standard deviation or a 95% confidence interval. And it's always good to use Excel to make your life easier.